I request all the participants to assemble at the auditorium and kindly be seated. We will begin shortly.
Hello.
As we are about to begin, I request everybody to be seated in the auditorium. All the participants are requested to be seated in the auditorium as we are about to begin immediately. A very good morning to everyone and a warm welcome to each one of you. It is a moment of pride and joy as we gather here at Sharda Krishna Homeopathic Medical College for the National Seminar 2025. prayer. I request all the audience to kindly rise from your seats for the prayer song. Kindly be seated. To symbolize the light of knowledge dispelling the darkness of ignorance, I now invite Dr. C.K. Mohan sir along with the other dignitaries to light the ceremonial lamp. I request Dr. C.K. Mohan sir along with the dignitaries to light the ceremonial lamp. Please do us the honor, sir. Our floral tribute to the founder of homeopathy, Dr. Samuel Hahnemann. I invite Dr. M.C. Bhavya ma'am, trustee of KV Education Trust, to garland the portrait of Dr. Hahnemann. Ma'am, we kindly request you to garland Mada Amritama's photo as well. Thank you, ma'am. It is my pleasure to invite Dr. V. Satish Kumar sir, Research Coordinator, Professor and Head, Department of Homeopathic Repertory and Case Taking, to deliver the welcome address.
The respected dignitaries of the dais, esteemed guests, delegates, faculty members, and my dear students. A very good morning to each and every one of you. It gives me an immense pleasure and a privilege to extend a warm, heartfelt welcome to all of you to the prestigious National Seminar on Capacity Building in Research and Biostatics for Homeopaths. We are truly honored to have Dr. Ishwara Das sir with us with delivering an inaugural address, sir. It's an expertise in the research and policy in the domain of Ayush added an
the experiences and evidences. When you give as a practitioner, he is happy with the experiences which we gets from a patient. To that extent, homeopathy has become popular among the patients and practitioners. Yes, we have seen homeopathy has been working on various clinical fields. In certain areas, it works far better than many other medical systems. In some areas, it doesn't. When we want to give an academician, when we want to become a teacher, when we want to become a guide, when we want to become a researcher, you have to see critically what are the principles and whether the principle is complacent with the existing scientific explanations. That is a big challenge which homeopathy is passing. But definitely, some of the innovations which has happened in biomolecular medicine, biomedicine, and our research councils has given some way forward in explaining some of the principles of homeopathy more rationally. Sir, to the people who are not homeopathy, yes, we have basically homeopathy is based on 7 cardinal principles which Hahnemann has postulated as the foundation of homeopathy. Out of these 7, many of the principles were not in a position to be explained on science, on the contemporary science. This is a fact. But most of them were on a philosophical level. So, but homeopathy has been working. Homeopathy worked in cholera, homeopathy worked in scarlet fever, homeopathy worked in plague, so many infections and so many pandemics. Homeopathy has worked. But now somebody asks what medicine you have given it, how it has worked, why it has worked. The explanation becomes difficult. That is where what happened in the recent COVID also. Now with the help from the scientists from other fields, a biostatistician, one of the most well-known biostatistician is here with us, Dr. Pannuraj. He knows how to manipulate the data to your advantage. Am I right, sir? Medical data are always manipulated to make your advantage and disadvantage. This is happening. Yesterday I saw a report that yesterday one of the scientific journal has published an article that a Bangladeshi boy who has taken acid sulfuricum 30, he created a havoc in his immune system and created whole body erythemas and infections. Immediately that has been published in a scientific journal that homeopathic medicine can produce adverse reactions. The problem is whether it was because of acid itself or it was a disease which the boy was having earlier which has came out. We don't know. Those data are not available in that article. So what I mean to say is that such new challenges are also coming into homeopathy. As the popularity of homeopathy is increasing, more and more challenges are also coming. We know that in COVID, homeopathy Carcenicol has done a lot of positive work, but when the data is analyzed with scientific tools, the results were not encouraging as we perceive it or we claim. That is where this medical technology, medical education technology and healthcare technology. These are two things. There are different healthcare technologies, and now in homeopathy this medical education technology is being introduced to use the technological advancements in science in medical education. There are a lot of technological advancements in medicine, like in human genomics, in nanotechnology. All these things are known to you. These are the things which are happening, recent advances happening in artificial intelligence. People say that in 2020, 45, there may not be a requirement of physical doctor required to treat. This is what is happening. Artificial intelligence and human robotics may be able to take care a major role of the treatment which are happening now. But then there will be a role for human endeavors and human interferences, right? So we have to go a long way. During that long way which we have to go, today we are making certain small beginning, and all these experts are going to talk on the topic, their respective topics, and give you a different direction than in your thinking. We all have focused thinking on the 7 principles of homeopathy and Hanuman in homeopathy. Can we challenge homeopathy? Can we challenge the principles of homeopathy? Challenge means not to remove that or discard it, but to bring better explanations, right? A better explanations will help us to sustain the growth. That is what we are looking forward, and the experts are here. I'm not here to take too much time on the intricacies of the topic. First of all, I want to congratulate the research methodology and biostatics department of Sarada Krishna Homeopathic Medical College, and the newly introduced medical education technology unit, as well as the internal quality assurance department. All the three departments can jointly work on certain areas, help you to have a new way of thinking, an innovative thinking, and help you to go further in your research pursuit. So your MD program may be a beginning of your quest for new knowledge. So new knowledge is always going to add new feather to homeopathy and expand the outreach of homeopathy in public health. Thank you very much. Congratulations to all the participants here. Congratulations to the institution. Sharada Krishna Homeopathic Medical College is one of the best institutions in India. They have taken this medical education technology unit, and all the best for this unit to come forward, to come in future. Thank you very much, and all the best. Thank you.
Thank you, sir, for your visionary words and valuable insights. Now, I invite Dr. N.V. Sugadan, sir, Principal of Sharda Krishna Homeopathic Medical College and Chairperson of the MET unit, to deliver the Presidential Address.
team of very motivated and dedicated members, Dr. Priyanka PS, Dr. Sanju S, Dr. Gokul Krishna, for all the tiring efforts for conducting this program. I wholeheartedly thanking you. I would like to extend my sincere thanks to all the delegates, PhD scholars, professionals, postgraduates, interns of our institution and from other various institutions, because of whom we cannot make this event possible. Now I show appreciation to those who have been the strength of the program, the ICT Department of SKHMC for the wholehearted support to make
Once again, good morning. Now, my role is the moderator. My duty is to introduce the faculty. Dr. C. Ponnuraj, Scientist and Head, Department of Statistics, National Institute for Research in Tuberculosis, Indian Council for Medical Research, Chetpat, Chennai. Sir is his education, sir, his basic UG from Department of Statistics, St. Joseph College, Trichy, Bharadasan University, Tiruchirappalli, and from there PG from Department of Statistics, University of Madras, Chennai, and his doctorate in statistics from the University of Madras, Chetpat, Chennai. This is a survival models of clinical trials with the treatment of patient interaction. His research experience since 1998, his research experience controlled the clinical trial and medical statistics. PhD gave 9 students, 4 completed. One from Bharadiyar University, University of Madras, and Annamalai University. He has more than 121 publications in scientific journals. I think it is this profile I got it earlier. Now he has more publication and more students are there. He has published the book title of Bayesian Frailty Models, Adhes of Chinnayan Ponnuraja and Perumal Venkatesan. The book publication. The research project ICMR funded project extramural ongoing 2. The research project principal investigator non-ICMR funded project extramural ongoing 1. Award the Young Scientist Award by the Indian Society of Medical Statisticians 2020. Membership and scientific bodies. Member of Indian Society of Medical Statistics. Member of International Biometric Society of the Indian Region. Member Tamil Nadu Statistical Association. His research area is survival analysis, data mining, big data, data analysis, meta-analysis, machine learning. So in which, and also he has presented so many national and international seminars. So in one expert person, you can interact with them. Already our students are familiar with that. In this sense, I welcome you, sir, to the presenting this session. Thank you very much, sir.
Yeah. Very good morning to all. So this presentation is more related to research methodology and introduction about biostatistics. So you know how important the statistics is for any research. It is very mandate for every student, irrespective of any discipline. They want to prove their research is a valid one. So this aspect, my presentation is like some slides related to the basic concepts of research methodology, and subsequently I will move forward to statistical concepts from the beginning. That means with the basic level. So this is not, the statistics is not for statistician. The statistics is for non-statistical backgrounds graduates. So I just want to start, maybe we can see what do you mean by research, why we need to insist. So this is the entire combinations of kind of data, from the data, the information, from the information, knowledge, from the knowledge we can get our final conclusions about how you are going to generalize your results. So these four are interlinked with each other. So of course you need to play with the science very carefully, then only we can validate. Sometimes you may not succeed with whatever you have. So irrespective of any kind of research, so the complete literature review is very, very important. So from there we have to start our research. So once I want to prove that this is a valid research or not a valid one, it is purely depend on how much I am in depth with the knowledge generated based on the literature review. So this is the kind of a way we have to initiate, especially for medical research is very important than compared to any other research available in the global. So these are the steps. I just want to say, like the research process can have, this is the basic steps we need to have. So formulating the research problem, that is very important. Subsequently, the extensive literature review is another important points we have to keep in mind before choosing your research problem. Then subsequently the hypothesis, it's more about, we have always tried to have how the hypothesis can be framed and what is the need for we need to have the hypothesis. What exactly mean of hypothesis? Then we can develop the objective. Subsequently we just move forward for the preparing the research design. Research design as well as the sample design is very, very important. As like the skeleton of the building as well as the blueprint of the building, we just want to have the research design as well as the sample design. Then collecting data. Before collecting data, we have to ask many questions. Why we need to collect, whether the data which is able to get answer for our research problem or not. Accordingly, we have to travel. Then finally, we have to do the analysis. Up to analysis, it's fine. Then subsequently move to the 8th point, like generalization and interpretation. How this is correlate with the existing scenario, whether this is proved statistically as well as clinically, that is very important. Whatever you have take up the process, whether whatever you want to conclude based on the analysis component, it is more related to the real scenario or the clinical scenario or not. So being a statistician, I cannot take decision on the way I have to analyze the data. Say for example, we always depend on the significant factor will be the important factors. The non-significant factor will not be given that much importance. So it is not meaning like I have to correlate with the clinically whether it is significant or not. So that means both the statistics as well as clinical significance is very, very important for this kind of a medical research. Then the 9th point will be like a preparation of the report. So that will shows like what you have achieved. From there we have to, whatever you have achieved, the current scenario will be the root cause. That means the prior information for the subsequent research in continuation of the process. So research as well as research methodology is entirely different. Research is kind of the research method, whatever the technique you are using, how the research can be elevated in what are the tool we are using for the technique. Whereas in research methodology, it is a complete platform how you are conducting the component. That means the science of understanding how research is performed methodologically. So that is the way we have to distinguish between these two components. And here the research methodology have a varieties of difference. Probably it consists of introduction and research method, research questions. Everything is as like I have shown the previous steps. This is more related to the research methodology component. So all the components are essential. If you eliminate any one of the component, this may not be a complete research methodology. If you feel that the research problem is not a necessary one, you know very well about all those components, but however, whether it is knowing or unknowing, we have to state the statement problem is essential. That is the important component. It can be categorized in a broad segment like a general category, as well as research design, then data type, as well as purpose of the study, then subsequently nature of the study. Each segment have their own capacity. Suppose if I want to do a general category, what are the research I can usually develop, whether it is related to quantitative or qualitative. So quantitative, it is amount of effort we need to pay more than compared to the qualitative. The qualitative is, though this is not a common, whereas majority of the study is related to quantitative, it consists of large amount of component available. Subsequently, if you are coming for the research design, whether it is you are planning for the exploratory design or conclusive research, these are the way. And data type, whether you are depending on the primary data or the secondary data. So more related to every research will be depending on the prospective nature. Retrospective nature, it's very rare, and it is when compared to prospective, retrospective is very less. So prospective nature is always, we believe that the progression of the research, it is true of course, even in the retrospective will be the fundamental for initiating many prospective research. So irrespective of anything, probably you are whatever you are generating the prospective data, it will be useful for retrospective later, wherever you have missed out some of the component. So ultimately the information, since I am a medical statistics, I know pretty well about the importance of data. Whatever data from the medical points of view, it will be a treasure for any kind of a research. We have to preserve the data in such a manner, whether you are using currently or not. Of course, it will be useful later component. So that's a reason every component we have to preserve the data. That is very important. Whether you are storing electronically or paper source document, there are strategy over there for the clinical trial management system. If you have kind of a system, that will be fantastic. There you need to develop kind of a treasure. That is a gold mine for doing any kind of research. So of course we can plan for any purposive study, whether this is applied or with respect to fundamental, or it is a nature of study, descriptive research or analytic. These are the categories over there. So anything related to these aspects will be types of methodology. This is a research type. Maybe we can say this is a quantitative, qualitative or descriptive research, analytical research, many things. Each one have their own structure, accordingly we have to travel. Ultimately the steps involved in each study will be similar, but the effort we have to take slightly varying nature. So whatever research methodology you are taking, accordingly the pattern also will be slightly changes, but ultimately the structure will be very similar for irrespective of all. And these are the steps for preparing research methodology. One is the focus on your aim and objective. That is the one thing that is very important. The second thing is identifying research methods that suits the research problem. So the feasibility also in addition to account in the second steps. And the rationale for the selecting particular research method is another evidence that we have to create. Whenever you are stating your research plan, what is the rationale behind that for selecting the research component? That is very important. So if you take that one, so the conclusion will be quite easy. If you are not taking the rationale, how you have to travel, this is a vague way you have to plan for your collection as well as progressing research. Always, as soon as you identify the problem, what is the rationale behind that? You just ask why you need to choose this kind of a topic, why you need to take this kind of a problem. So that will give you kind of a more answer. So this is mandate. Ask in every step why you have to take, what is the need that you have to initiate, what is the rationale behind that for addressing this problem. That is very important. And consider your component, that means the participant is very, very important. That means it shows the flexibility or it is feasible of the study. Then finally we can do analysis in different data. According to the data type, the analysis pattern also will vary, and maybe you can generalize results after doing the 6 steps. And here we can say sometimes I just want to have kind of a mixed method. If I'm preparing qualitative, there is no problem, or quantitative, there is no problem. If we just want to mix together, that is an important thing that we have to address this component. The mixed method is one of the key component. Nowadays it is also more common in irrespective of any research problem. So here it is kind of a way we can combine these two aspects together, and accordingly the results as well as the integrated component will be interpreted as per the way we are conducting the qualitative as well as quantitative nature. And here we can see this is onion, as like the component of onion, whatever you are targeting in the midpoint, this is the way. This is a very famous model in the research. This is called onion model. You just look at the component, each layer have their own merits and their own steps. So we usually say that it doesn't have inside the onion, it is not meaning. There is a quantum over there. There it shows like the way you have to progress. So this is a very famous model, like we can have a different layer of the research, whether this is a deductive logic or inductive logic, that is a 2 component. So deductive logic, inductive logic, that is a one differences. If you are developing theory and subsequently you are getting result, that is one aspect. If you are developing data and subsequently you are coming for the theory, that is another component. Either way you can plan. So research could be like planning the component and subsequently you ended up with the result. That is one thing. Second thing is developing data and based on the data you are developing theory. That is also there. So this is the simple example. It is a difference between statistics and mathematics. So mathematics is more related to deductive logic and statistics is more related to inductive logic. This is the concept we have. Either of the arm we can do as per the component. If you understand each component of the onion model, the research will be quite easy. So these are the elements of research: the clear and specific component and sampling, data collection, data analysis, type of method you are using, time frame, ethical consideration and resources. So without ethical consideration, any of the research cannot be proceeded. Even the ethical concern is very, very important for whenever you are dealing on research with respect to human as well as in the animal as well. So ethical is one of the key component which is evitable for any kind of a research. These are the basic elements. So whether you have this kind of elements in your research or not, that is very important. Accordingly, you can take each steps carefully and proceed further. The research will be quite easy. And there are pros and cons related to qualitative research, especially why I am saying like the qualitative research is not that much common, whereas in quantitative research it is very common. So if you take quantitative research, there is another component that you have to address is you just want to have the sufficient number to prove or disprove your hypothesis. So the sample size is one of the important component for any kind of a quantitative research. Whereas qualitative research, it is not necessary that you need to maintain the number, but however you can generate evidences with the available resources. So I don't have any prior knowledge for calculating sample size calculation. I can plan for any pilot study. So the pilot study is a root cause for developing the major trial. There I have to validate my research. You know very well about in this, especially for this kind of Indian system of medicine on homeopathy research, the lack of controlled clinical trial is important component that we have to address. So once you develop kind of a controlled clinical trial, definitely there is a progress on the research, especially on this kind of a particular type of medicine. We need to validate. We have done a lot of evidences, but we unable to show what is the evidence behind that. Whatever you are showing that kind of a valid component based on some kind of a drug, it should be validated with sufficient evidence. So how you are going to take the evidence or how you are going to collect the evidences for the validation of your findings. And the other component, these are the types of research design. Normally the research design will be like descriptive, experimental and correlational as well as diagnostic and explanatory. Sometimes you will ended up with any of the one. It is not applicable for whatever you are choosing the problem, irrespective of any particular study design. It's not. I am showing just a broad head. Whether it is your end that according to the objective you have to choose your proper the types of study design. And we can talk about much about the research problem, research methodology. Especially in medical research, these are the way we have to identify what kind of a research you are going to, whether this is basic research. With respect to basic research, we have two arms like theoretical as well as applied. So according to that, we have many component over there. And coming to the clinical research, we have experimental as well as observational. Under experimental, we have steps of study design. According to observational, we have the same way how we have to process. And coming to the epidemiological study research, the same as like in the clinical research, experimental, observational is there. So these three are comes under primary research. If I want to do kind of a secondary research, I can do meta-analysis or systematic review or the review of literature, whatever it is showing in the right arm. So there also we can do. So I don't have any data, but however I can generate kind of evidences that which already have published, which we can relate with a common platform. Accordingly, we have to select study to the meta-analysis Here, these are the steps over there for the real world as well as the biostatistician. So always, this is more related to data driven. Data driven, generating data, traveling data, and what nature of data, how I can go to the final results. I'm taking the data from the world, that means existing scenario. I'm doing my process. Whatever the results is close to the existing one or not, that is a challenge. If this is not close to the existing challenges, again I'm going back for the real world, taking the data, doing my research. This is kind of a complete cycle. So here in statistics, we can say we can lie with the statistics. That's not a problem. But without statistics, we cannot get the truth. That is true. We can lie. It's of course we can lie. There is not an issue. As like Professor mentioned, statistician manipulating data. It is not like a manipulating data. The manipulation with respect to how this is possible to achieve the target. So whether the data is relevant to the objective which I have chosen is not. So that's the way we are traveling. It is not like someone is not getting significant, I try to make it significant. That's not kind of a thing. That is actually, it is a manipulation of the data. But the manipulation in the sense, I am collecting data in a proper way, how best I can able to achieve my results as per the theory, as per the objective I have planned. So this is the reason. And here also there are issue like, this is more related to probability. And I just want to say, it is kind of evidences. You look at the regression component is quite interestingly and vast applied statistical component in any of the research. But it is a pity thing that whatever the results they have presented, they have applied 85% in wrong attitude. Whether it is knowingly or unknowingly, I don't know what happened for them. And even sometimes I could. So the thing is, you are the root cause. Whoever is doing kind of investigator, and you are the people are the prime for developing the data. From your end, I have to get the information perfectly. Otherwise, it goes wrong. So I need complete information. As like you are inquiring what is the problem for the patient. If you are not thoroughly inquiry about the nature of the disease the individual is having, without complete intervention or inquiry about the patient's nature, you cannot prescribe medicine. Same way, I cannot do my analysis without getting the complete information from the medical persons or the investigator. So then only the problem can able to solve. So why we need to study statistics? I am accumulating large amount of data. I just want to make a way we need to conclude the data which it is nature. The professional way of defining kind of a handling the data, it is obviously we can say this is a statistics. And there we need expect kind of a statistics, and this is the way we have to define the statistical problem. So statistics, look at the statistical definition, it hidden three component. One is timely present, and the time management is important, money is another important, and the third one is manpower. So with the minimal cost, minimal time, with the minimal resources, how best I have to achieve my results. So that's the reason the And here we have technique like a mean, median, mode and frequency, and here we have correlation, t-test, ANOVA. There are many statistical tests available. Under this we have two arms. One is estimation, another is testing a hypothesis. Estimation is purely on confidence interval, whereas testing a hypothesis, it's account more about confidence interval as well as the power of the test. And here we have two approaches. If the data follows normal, I have a planning to have this is kind of a parametric as well as non-parametric component. So these are the simple structure is there to understand the statistics. So if you know this structure, then you can plan for statistical test according to the data is quite easy. So here it is more related to the collection of data. We will talk about in terms of data. So if I am asking you what do you mean by data, obviously your answer will be collection of information, but collection of information is totally a vague answer, but it is not the way. So the information is entirely different from data. How the data can be, sometimes I used to have collection of large amount of data. I can coin this word as a datas. There is no word datas. The data itself, it's a plural form, and data is kind of the singular form will be datum, and it is observation made on a population or on a sample. So it's something given. The meaning of datum is nothing but something given, and it doesn't have any kind of a way we need to have the information. So that means information is entirely different, and here the difference between the theoretical difference between data and information, it is kind of a raw fact or no context or just numbers and text. Read like a LKG student, that become data. Even the data, if I am pronouncing the data itself, it's a information. If I am pronouncing like a DATA, that is data. So that's a way we have to understand the difference between data and information. Whereas information, you have a data, you calculated mean. The mean itself, it's a information. You have a data, you draw some graph. The graph itself, it's a information. Like we have component. So one process to another process will be different as information. So I have kind of a classical example like how we unable to form a word using the 6 letters. The same way you have to pronounce. Irrespective of any word, you try to pronounce the as like in the first word, ABCD like. So look at here, the last word is G-O-O-D. I can able to pronounce this is a word like a good, but it is not. If I am saying good, that is information. If I am saying this is G-O-O-D, that is data. As like I have a different component with respect to numeric also, how the numerical form can be clubbed into a different way. If the same number can be diluted or can be reframed in another format, so I could able to write in terms of date of the particular month of the particular year. So another way, the same number can be rewritten in terms of another way. This is average starting salary of our data, our doctors, of course, I believe so. And here it is kind of a way. So we usually called a data file consists of a definition file. I am presenting that way. So left side you can look at data, and the definition file look at like the information. It has it kind of a vary. So I just want to dilute whatever component I have written in the document. The database always not necessary to have all information together. Maybe the information will be hidden or it will be in a separate file. So one way we can prevent the component. So look at the number. While seeing the 6,31,000 people can able to identify this is a pin code of a place, that is adding context. So if I have some kind of idea, I can able to say something, it is more related to that component. I can say this is a way we have to understand about data and information. And the component, you look at the data, nobody knows what it is, but it is a numerical number. It has 2 decimal, that's all. Once I am drawing this kind of a graph in the right side, so I can say this is information. The drawing graph itself, information. Ask some question, what is the pattern over there? Whether it is increasing trend, that is knowledge. If it is increasing trend, what is the decision you are going to take? That is wisdom. So it is increasing trend. Of course, according to stock price is increasing, again you need to buy more stock or you want to sell the existing stock for more profit. If you want to take that decision, that is wisdom. So here the information itself, there are 2 things are hidden. One is knowledge, another is wisdom. So you look at here the image, it is the way we have to develop kind of a database. All these composition are likely to define this is a database and how the database consists of. So as such the data, when but in terms of knowledge, information, knowledge and wisdom. So you ask whatever the W is over here, accordingly if you can able to get answer, then you are achieving the one stage. And here, this is a types of data, common things. Left side it is a qualitative. So qualitative I can give kind of a way like a categorical, and right side it is a quantitative. So qualitative it is only two option binary, it is more than two option, either nominal or ordinal. So nominal there is no interrelation between each other. Say for example, I am just naming the colleges over there. If one college is greater than the other colleges, if I am relating that one, it is an ordinal one. It is order magnitude. Something like qualitative data, feeling of pain, how the pain will be measured. So it is more related to order, mild, moderate, severe. Income, low, middle, high. These are the way we can. So if you have any sequence that is an order according to some criteria, whereas in nominal, it doesn't have order criteria. Whereas in quantitative, discrete, it is only whole number. I can able to count how many male over here, how many female over here. Whereas in continuous, it doesn't have, you cannot interpret completely. One of the good example is age. If I'm asking someone age is like 25 years, the 25 years is not the complete age of the particular individual. So they have probably some months, probably say some days, some hours, some minute, even seconds. While you are progressing with the seconds, when time progresses, your age also progressing. There is no concrete time point for defining particular age. If that kind of instruments will be classified as a continuous. There are many examples like a height, weight, whatever it is. Weight according to one decimal, we are restricting one decimal, but it has infinitive. Decimals will be quite enough. Based on some circumstances, we are restricting certain point. So or otherwise, whatever way you are measuring certain thing using some kind of instrument, obviously that falls under continuous only. In continuous, we have kind of a criteria. So this is the way we can define nominal, ordinal, interval and ratio. This is scale measurement. The previous one is like a types of data. Here it is a nominal, naming something, ordinal, order according to some criteria, but it's also name according to order criteria. An interval, I can say like the difference between interval and ratio, it's more related to equal to 0 or not equal to 0. Sometimes my 0 also have some kind of a meaningful value. Sometimes I don't find any 0 as a true origin. Like we can have. So suppose if you have a nominal data, what are the way you have to represent? So this is naming something, maybe you can present in terms of numbers as well as percentage, or you can represent in terms of any graph or any chart, whatever it is. If you have ordinal data, the same like you can present it as like in the previous, you can present number of cases in each group, what's the percentage, and how you can represent in terms of any graph or in terms of any chart you can present. When coming to the discrete data, again you can do that way, you can able to count how many cases. Whereas in continuous things, you can see this is the example, and you have to represent in a certain procedure like continuous data, dealing of continuous data. It is really challenging one. You have to plan what type of a test, and even if it is a continuous, you have to assess what nature it is. Statistician always say this is a normal or non-normal related. What do you mean by normal? What do you mean by non-normal? We can see. And before that, we just want to know the understanding about interval and ratio. Interval and ratio also, it is a continuous form. The only difference is 0 equal to 0 ratio. 0 is not equal to 0. It is an interval. See, one good example, my car is running 0 km per hour. There is no movement in the car, but 0 indicate true 0. But today's temperature is 0 degrees Celsius. I cannot say it is a pleasant weather. There is no hot, there is no cold. 0 degrees Celsius in the sense you know very well about it is a freezing stage of water. But one 0 doesn't have any value, another 0 has some meaningful value. And even if you want to represent kind of a way the interval will be, there is no true 0 origin. You can have a positive as well as negative also in another direction. But whereas in ratio, it doesn't. 0 is the true origin. That is the difference we have to. Of course, I too agree. The way we need to present with respect to interval is very, very limited. But however, according to the data, I have to understand the complete understanding about the interval. In case 0 taken place in the value of the database, which is relevant to interval, I should not omit So 0 also having some kind of a true variable. Sometimes people usually having kind of a tendency, 0 doesn't meaning you have to remove all those things. We never bother about 0, simply we remove. But we have to understand whether this is related to a ratio or interval. According to that one, probably I may contradict with the mathematical definition, but of course this is true. 0 doesn't have any meaningful, then you can do, this is a true 0 origin means it is a ratio. It has some meaningful, it is an interval component. And here I have some example, but yeah. So if you have qualitative data, so these are the way you have to present, either in terms of tables or graph or number. With respect to number, I don't have any category to do any analysis. I can present only percentage or the number of cases. Whereas coming to the quantitative data, there are many things available. So I can present table as like in the previous, doing the graph. Even sometimes the graph also which I am showing histogram, it is mainly for normal data. And the box whisker plot mainly for skewed data. So how you have to understand? So these are the basic things. While you are seeing any histogram, that the histogram will tell you about the nature of data, whether this follows normal or not. I'm talking about normal or non-normal, how to interpret normal or non-normal in a proper example. So look at numbers. In terms of continuous number, there are a lot of challenges. I have to assess whether it follows normal or non-normal. Accordingly, I have to choose my test procedure. Yeah, these are the sources of data we usually have. Probably I can collect from existing record or doing survey or doing experiment. With a survey, I am having only complete enumeration or the sampling concept. And this is the simple structure. How to understand the simple structure? This is purely on matrix form. If you can able to identify rows and columns easily, then this is the structured data. Some of the things, the data itself, we have unstructured data. What do you mean by unstructured data? Taking some image, like a X-ray image, it is unstructured data. Or taking audio data or video data, these are all unstructured. I cannot do analysis directly. I have to do some formal procedure, how to structure it, even if it is an image or whatever it is, then only it is possible. So if you can able to classify rows and columns clearly, then the problem will be solved. You can choose any particular analysis, you can very well, you can go ahead. That's not an issue. So the rows are individual's record, that means patient's record. The columns are their characteristics like age, weight, of an individual, like you can mention like. So here, this is the data collection sources. I can say primary data collection, what are the sources available like a statistical method, survey, polls or interview, Delphi technique or focus group. If you come up with secondary data like some kind of a reports, wherever you can see reports, based on the reports I am collecting data, this obviously belongs to secondary data component. Something like we used to common things, when I can use mode, median, mean, and this is the nature we have to. If it is central tendency or dispersion, always you just keep in mind the measures of central tendency will be assessed with the measures of dispersion. We know very well about how to calculate mean, how to calculate standard deviation, but the problem is how to relate these two. This is very important for any kind of research. Then we can classify whether we are following normal or the data is normal or whatever you have done is correct or not, you can validate. And these are the things we have to choose as per the nature of data. Suppose if I am having the interval as well as scalar data, all the three will be applicable. Mean, median, mode is applicable. Sometimes if I am handling ordinal or nominal data, there are certain procedure available. Say for example, ordinal, nominal, the mean doesn't involve. If you have data related to ordinal or nominal, don't calculate mean. So the mean is only for continuous data, either it could be interval or ratio, but another condition, it has to follow normality. So that distribution also very important. So these things are very common. So dispersion also, it has some kind of a merits according to the nature of data we have to do. Interval and ratio, definitely we can able to do. Standard deviation, interquartile range and range, it is applicable. Whereas in ordinal data, certain things are not applicable, especially standard deviation is not at all possible to calculate that component. So here it shows how you have to say the data follows normal or non-normal. According to the definition, I just want to say this is a normal distribution. What do you mean by normal? How this can be interpreted in an easy way? Look at this graph, you can understand. The first top is normal, where you can identify all the points, mean, median, mode are in the same line. That means all are equal, that's all. Whatever I am, suppose you have a data, you calculate mean, median, mode, you are getting similar results, you assume that the data follows normal. If you are having different results, as like in the bottom, whether with respect to skewed, so the bottom lines either in the respective of positively skewed, negatively skewed. This is the way we have to understand. If the mean is higher, positively skewed. If the mode is higher, that is a negatively skewed. This is easiest way to understand. See, you know very well. It is not necessary that you have to have a, as usual, like in the statistical formula to calculate all those things. You know very well how to calculate mean, how to calculate standard deviation, or how to calculate mode, how to calculate median. Then you can relate this component. It is follows normal or non-normal. It is not necessary that you have to do a high-end statistics for checking the normality. It is there. You can learn later. But for the basic data, this is the base rule for understanding the nature of their component. So here, I just want to say here, there are some constant value over there for each criteria. Suppose my confidence interval like a 95%. That means I am giving allowances for the type 1 error is 5%. So it is the usual scenario. So in the book or in the software, it is showing by default. Don't say like a by default concept. There is a criteria. As like the biological example, based on that they have defined 95%. Even for the biological data, if you are thorough with your data, it is so good enough. There is no skewed at all. You can go even 99% also, biological data. And I'm always worry about the error. So my diagnostic procedure is always better. I believe, so according to a medical person, I believe that the nature is always true, but sometimes it goes wrong. So if it goes wrong in which aspect, accordingly we can define this is type 1 error or type 2 error. So statistically there is a rule, but here statistics, it may not be sufficient to prove this kind of a rule. Also I need to confirm with the clinical evidences. You can frame which is according to the hypothesis, you can plan which type of error is more serious. I know these two are error. Which type is more serious? So this is the problem. You assess clinically, you can define. So I just want to try. In some situations, you cannot take decision based on the statistical significance alone. You have to get some more addition with respect to clinical significance, then the decision will be perfect. So how much I can able to give allowances for type 1 data? It is a 10%. At the maximum scenario, type 1 error for 10%. Worst scenario, I have to maintain 90% confidence interval. And the other one is type 2 error is, I can go even 20%. That means 80% is the power of the test. So the complement of type 1 error is confidence interval. The complement of type 2 error is power of the test. So if I am doing any clinical trial, I have to consider these two. If I am doing any estimation aspect, I just want to consider only one type of error. It's not necessary you have to travel both. So here, this is the true scenario. Normal look like here, negatively skewed look like here. The skewed with respect to left, skewed with respect to right is the indicator for identifying skewedness. And here we can say, if I am saying normal, all three are equal, I too agree. Which one is ideal? Mean is ideal. If the data follows normal, that means all three M's are equal, then you have to present the mean. And I will tell you the another rule also, so slightly later. And this is the another scenario where we need to concentrate. This is a positively skewed. This is the way. When mean is higher, you can define this is a positively skewed. When mode is higher, you can define this is a negatively skewed. Irrespective of positive or negative, the mean is not an ideal one. The median is the only measurement you have to calculate. For the skewed data, median. For the normal data, mean is ideal. So these two things are very, very important. Don't represent in the other way. So here, sometimes I can able to present in terms of graphs. There are graphical procedure available especially for normal. There are graphical procedure available especially for non-normal. See here, some of the way we have to present with respect to graphical. According to nature of data, we can select the right choice of the histogram or whatever it is. Histogram mainly for normal data, and the box whisker plot is mainly for skewed data. But These two are continuous related data. Rest of the other things you can play with nominal data or categorical data, whatever it is. And here the histogram, here it is one way we can represent with the normal related. And here it is a, when the data is skewed but it is continuous, then the box whisker plot is ideal. And I just want to present some kind of idea. This is the way we have to present the data component. So this is order related component. And one important thing, like the second rule for assessing normality, the standard deviation is take place, a vital rule. The one is all 3 M's are equal, then you can assess the data follows normal. Sometimes while you are presenting your result in the manuscript, you are not attempt to present along with your data. Only result alone you are going to focus, or you are going to present in your manuscript. How can I relate with the 3 M's are equal? That is impossible. So I am just correlating with the standard deviation. Whatever the standard deviation you are calculating, assume that the first set of data consists of all the values are equal, then the mean as well as standard deviation, good. There is no problem. Mean is 7, standard deviation is 0. The standard deviation will be calculated based on the mean relating with each value. Mean versus first value, mean versus second value, what is the difference? I am calculating standard deviation that way. Why I have to present here mean and standard deviation? The standard deviation is the assessing tool for the mean. Whenever you are representing with respect to mean, this is your duty that you have to present along with the standard deviation. So the mean is always accompanying with the standard deviation. There is a rule. How you have to relate? The first set of data, it is a perfect. What you have done, the mean is perfect. There is no problem. You can calculate all 3 M's, that is also equal. Then the data follows normal. Ultimately, the first rule as well as second rule also satisfying the same component. There is no issue. What you have done is correct. Look at the second data. Again, the second data also almost similar as like in the, again the mean will be similar and standard deviation slight differences. This condition also perfect. You can calculate first rule, all 3 M's, you will get similar result, and you can conclude what you have done is correct or not. It is perfect. The problem is the third set. Again, the third set you calculate the mean will be 7. Again, the mean will be 7. How I have to take a decision? So irrespective of all the 3 sets, the last set, what you have done is wrong, totally wrong. You calculate all 3 M's, you will have a different result. Sometimes mode is not possible. Also, you relate the standard deviation. There is a rule for standard deviation. The rule says, whatever you have done, you calculated the mean is 7. The standard deviation should be less than 50% of your mean, you can accept. If it is exceed 50%, then there is a issue, the data is not a normal. There itself you can assess. It's not necessary you need a fantastic statistician to assess the data. On your own, you can assess the nature. Third set is totally wrong. For third set, you have to change the test procedure. Like this is not possible to represent mean. This is possible to represent only median, because 2 rules, all 3 M's are equal, that is one rule. Then standard deviation should be less than 50%. You check the third set, it is less than 50% or more than 50%. Definitely this is a more than 50%. Then the mean is not an ideal tool to represent. So these are the basic things we have to. So the duty is, if you are not presenting mean along with the standard deviation, there is a problem. You have to do. The people you always happen to see that the mean plus or minus always there in any manuscript or any book. It is mandate. So now we just want to know whatever we have seen. The mean, it is an average of the data. It is outliers. If it is there, it is so sensitive. Whenever you have outliers, the mean will affect. So median never affect, and this is also for the skewed data. And mode is most commonly occurred, and the range is spread of the data with respect to normal, and range IQR is the spread of the data with respect to non-normal data. It is a skewed data. And standard deviation, it's a one tool that how the values around the mean or not we can able to check. And the symmetrical data, all 3 M's are equal. Non-symmetrical data, all 3 M's are not equal. This is the crude way to understand the easy glossaries of statistics. And look at the right side, you can see there are component available how to check normal with 1 standard deviation, 2 standard deviation, 3 standard deviation, even 6 standards, 6 sigma concept is there now. In 6 sigma, we can expect 99.99996, that kind of it. Still it is lacking 0.00034 percentage is error. And here we can present the data. One is related to descriptive statistics, another is related to graphical. According to nature of data, we can present categorical, continuous, what way we have to present, and the similar manner we can present with respect to graphical illustration, categorical data separately and continuous data separately. This is the simple representation of the illustration with respect to descriptive, with respect to graphical. If you follow this way, maybe you have to narrow down the way you are going correct or not. This is one way you can assess. And the second thing is, whenever you want to plan for any statistics, you just feel free to ask these 5 questions. One is comparing one group or two groups. That is one thing. How many points over there? What is the number you have? Another one is whether the number, whatever the data, it's related to categorical or continuous. If it is categorical, binary, nominal, ordinal. If it is continuous, interval or ratio. Then the last one is, in case if it is a continuous, you have to ask. If it is a categorical, it's not necessary for the 5th question. If it is a continuous, the 5th question is vital, whether the data follows normal or non-normal. If the data follows normal, we have certain test procedure. Now this slide will give you more elaborate way how you have to choose your appropriate statistical test according to the data. So my always concern about outcome variable, and another component is exposure variable. So the nature of outcome variable, only 2 categories, continuous and categorical, and you just forgot about the survival component. Will be give you more information about later after completing that. Broad head for outcome nature is only 2, continuous and categorical, and exposure variable like a 1 group or 2 group, or it is more related to 2 time point, or it is more than 2 groups, or it is a continuous. Since this is a continuous related component, I have to check with whether it is follows normal or non-normal. If it follows normal, I have to choose appropriate deciding factor is nearly 13 checklists available. From the 13 checklists, I just want to highlight only one simple questions like irrespective of planning n number of objectives, the sample size calculation will be used for only one objective. That means the sample size calculation will be done using a primary objective. You have to plan for defining your objective like a primary and secondary objective. You can plan for n number of secondary objective. The option is yours. Whatever the answer you can able to get from the primary objective, you can plan for secondary objective, n number of things. And these are the other points. There are 13 common checklists for how to calculate the sample size and what is the way we have to plan. Study design is important, sample design is important, and the primary outcome is important. The precision, it is more related to estimation aspect. And the point we need to consider, these are the three ways we can use. Either we need to input as a proportion or mean. These are the two aspects for calculating mean. Odds ratio relative risk also comes under proportion. There is not a problem. So the input for sample size calculation either proportion or mean. And type 1 error, type 2 error also is applicable. Estimation, type 1 error will be allowed. For testing a hypothesis, both error will be accounted. And the population is another important, and whether it is one tail or two tail, always we can plan for continuous data or clinical trial data for two tail. And of course, this is one of the formula. Don't think this is the only formula. If you ask Google, most answer will get according to this formula. But this is one type of formula. Believe it or not, there are 200 plus formula over there. In especially for controlled clinical trial, we have large amount of formula applicable. And I just want to highlight this is formula for comparing two means. And here it is, I am saying this is a testing hypothesis. Testing a hypothesis, you just want to assess confidence interval. That means type 1 error, type 2 error together. Alpha is type 1 error, beta is type 2 error. If you happen to see these together too, then this is meaning of the sample size calculation is testing a hypothesis. And this is the way we have to interpret. And Z beta is the power, and Z alpha is type 1 error and test. And the difference will be like a effect size. And the similar formula for proportion. So I just want to highlight the component available in the sample size calculation formula. That's all. There is a constant value we'll be using. In case 95%, this is 1.96 is the constant value that you have to add. So whether you know or not, while you are discussing with your statistician, at least you need to have this kind of a basic information. And in case if it is more than 95%, 99%, the value will be slightly changed, especially this for alphabet 2 two-tail test. And these are the adjustment for the sample size. And this is the way we have to categorize according to study design. We can able to calculate the sample size and look at the sample size for epidemiological and randomized trial. According to controlled clinical trial, this is non-inferior, superior, equivalence, bioequivalence. These are the way ultimately we have to plan for
thank our Punrajat sir for giving a very nice information on the statistical part. We are all reached medical science in order to avoid mathematics in our life. But the previous presentation gave you some information that mathematics can never be taken away from your life, and statistics is very important. So your life again goes back to the arithmetic and the maths that you have studied and which you have discarded in some part of your life. So the researchers, again, you have to be very fond of mathematics. That's what the previous presentation has given you, and how wonderfully he has presented the statistical part, biostatistical part. And the next challenge in homeopathy and the medical science, as all of you know, is two things. To do a research, point number one is, as far as a medical professional is concerned, is the time, and number two is the financial issue that researcher may face. Time is very important because a clinician will have continuous practice and he may not get time to document all these things, and therefore that will result in not doing a research, or the documents will go without being opened. That is point number one as far as clinical research is concerned. And coming to the experimental research that is going on, the funding process or the financial problem will come up, and that will also make the researcher to get pulled back from doing the research. To cover that particular problem of funding, which homeopaths and all medical students face, we have our Dr. Shabrish B. To be very particular, as far as Sharada Krishna is concerned, the trust member of the KV Education Trust, Dr. Shabrish, who is a medical administrator of critical care and consultant in emergency medicine and critical care, and professor in emergency medicine, Amrita Hospitals, Kochi. To be very personal, for Sharada Krishna, he is the husband of our trust member, Dr. M.C. Bhavya. So, let us hope that this session, who has got enormous experience on doing so many researches, as far as the profile is concerned, he has done more than 28 research papers has been published, and that is going to give us a lot of information of how he has gone through 28 researches and 28 publications, and that too in emergency medicine. Let us hear from him, who is experienced in clinical assistant professor since 2012 and consultant in the same institute since 2020, and a professor in the same institute, in the same department since 2024, and also the medical administrator of the same department of Amrita Institute since 2025 onwards. So on behalf of the research department, on behalf of Sharada Krishna Homeopathic Medical College, and on behalf of the MET, and all those present over here, all the researchers present over here, let me welcome Dr. Shabrish Balachandran for session 2. It's a pardon from the research department. This is going to be a recorded version, as he is having some health issues as far as sound is concerned, but he'll be coming online for clearing your doubts, I hope so. So once again, I welcome Dr. Shabrish for the presentation.
morning, everyone. Respected dignitaries and esteemed colleges, dear students, then today is our faculty, Dr. Jayachandra sir. It is with a great pleasure and deep respect that I welcome you all to this enlightening session on ethical components of medical research. That today we are privileged to be guided through this important subject by none other than Dr. Jayachandran Nair CV, a renowned figure in the field of the medical ethics and the clinical research. Dr. Jayachandran Nair, Professor HOD, the Department of Pharmacology, Daleview College of Pharmacy and Research Center, Trivandrum, is widely respected to his academic depth, clarity, thought, and committed to promoting the ethical standard in medical practice and scientific investigation. He has done PhD in pharmacy from Delhi University in 2018 and also PhilESA accredited certificate course in laboratory animal science organized by Tamil Nadu University Veterinary and Animal Science University, Chennai in 2024. He is
Heart. Hear all the things through your ears. Whenever you are practicing, whenever you are doing research, whatever the things I am going